So, how does machine learning actually happen in practice? I mean, it can't just be magic, right? In this lesson, you and I are going to establish a useful framework for thinking about machine learning techniques. This is going to be our basis for thinking about the gradient descent algorithm. So, at the most basic level, what we're doing is feeding a whole bunch of data into a computer and it gives us back some solution, some answer. The thing that our computer is actually learning is the relationship in the data. So how is it that we can feed a whole bunch of data into our Python program and our program spits out a function that describes the relationship in this data? What are the steps involved in how our machine learns this mathematical function? In a very simple linear regression example, our machine learning program has had to learn the orange theta 0 and the green theta 1 parameters in this equation. And that's going to be on the basis of the data points that it was given. So you can keep this example in mind in what I'm about to describe to you, but this framework that we're going to talk about goes well beyond regression. And that's because many machine learning techniques follow pretty much the same three-step process to arrive at their solution. And here it is. Step 1 is to make a prediction. Predict what exactly? Well, the coefficients in our function, for example, the theta 0 and theta 1. Our machine is learning a function, so it has to start by predicting the coefficients in that function. Now, the very first time this happens, the very first prediction is pretty much like a completely random guess. So let's move on to step 2. After making the prediction, step 2 is calculating the error. In other words, we need to measure how good the prediction was. We need to calculate how far off we were from the data. And that's why we calculate the size of our error. And step 3 is the learning step. This is where we adjust our initial prediction. And this is the crucial part, right? First, we made a prediction. Second, we compared our prediction to the data. And now it's time to learn from our mistakes. Yeah? Having figured out how far off we were in the previous step, we can now make a change to the coefficients. But we're not done just yet, right? This was only the first run through. At this point, we're going to go back to step 1 and make a new prediction. This new prediction is going to have our modified coefficients. So using this new prediction, we once again calculate how badly we did and calculate the error. Hopefully, this time round, the error is smaller than the first time round. So having measured the error and how badly we did, we adjust our prediction once again. And then rinse and repeat. So in summary, there are 3 steps. Number 1 is predict or infer the theta values of the function. Number 2 is calculate the error and measure how far off we were in our prediction from the data. And step 3 is making an adjustment to have a smaller error the next time round and slowly learn the best coefficients. And this is the learning process. When we're writing our Python code in this module, this is how we can think about training our machine learning model. Now, there's actually a name for this kind of step-by-step approach that we just described. This is called an algorithm. An algorithm is a set of instructions for solving a problem. The Cambridge Dictionary defines an algorithm as a set of mathematical instructions or rules that, especially if given to a computer, will help calculate an answer to a problem. You know, the thing is, you and I probably more familiar with a different usage of this word, right? Having heard sentences like, my app uses an algorithm to predict if fans of one particular band will also like music from another band. So it's perfectly understandable that most people think that the word algorithm is actually a word used by programmers when they don't want to explain what they did. So before moving on to the next lesson, I'm going to leave you with a fun fact. The word algorithm actually gets its name from a guy, right? Muhammad ibn Musa al-Khwarizmi, algorithm. Now, I probably didn't pronounce that right, But in 1825, yeah, 1,200 years ago, this guy wrote a best-selling book in mathematics. And the Latin translators in the Middle Ages did an even worse job than I in pronouncing this guy's Persian name. So that's how we get stuck with the word algorithm. So anyhow, on that bombshell, I'll see you in the next lesson. Take care.